Sniper rifles are the surgical scalpels of the battlefield, engineered to kill with millimeter precision at astonishing distances. Today, we walk the line from raw metal to calibrated instrument and reveal how an AWM, an M40, or any modern long-range rifle becomes deadly accurate. This is factory truth with no myths, no glamour. From idea to digital prototype, every top-tier sniper rifle starts on a computer, not in a workshop. A team of designers, engineers, and ballistics experts spends months tweaking a virtual model by tiny amounts. They test recoil, how the barrel vibrates, how metal expands from heat, and how bullets fly in wind or at high altitude. Running these tests on screen finds problems early, like a barrel that bends just enough to miss, or a bolt shape that could fail under pressure. So those issues get fixed before any metal is cut. That virtual proofing means the design is already trusted for extreme ranges, often past 3,000 meters. Beyond the raw simulations, teams create dozens of iteration cycles. A change to the barrel profile alters harmonics, so they rerun recoil and heat maps. A different stock angle changes shooter ergonomics, so they test sight lines and cheek weld virtually. These linked checks stop small trade-offs from becoming big failures later. When the digital plan is final, materials are chosen and ordered as solid blocks. Aerospace aluminum becomes the single, stiff body for low weight and high rigidity. Heat-treated steel forms the barrel and bolt, so they survive massive pressures and heat. Reinforced polymer is used for lighter, non-structural parts. Those raw billets are then machined to micron tolerances, so the finished rifle behaves exactly as the simulation predicted. To bridge design and production, teams build real prototypes and test them thoroughly. Prototype barrels and bolts are pressure-proofed, headspace is measured, and parts are checked with borescopes and coordinate machines. Suppliers are vetted. Heat-treat certificates, material tests, and incoming inspections are required so every batch matches the model. Manufacturing planners write CNC programs, create assembly jigs, and define inspection checkpoints. Forging, casting, and the birth of precision parts. The heavy steel starts in furnaces hotter than 1,500 degrees Celsius, where it melts and is poured into molds that form the strongest, most stressed pieces: barrels, bolts, and internal mechanisms. After the metal cools, barrels move to ultra-precision automated lathes. There the bore is cut and rifling, spiral grooves inside the barrel, is carved. Rifling makes the bullet spin at thousands of revolutions per second. That spin stabilizes the projectile like a gyroscope, keeping it flying straight even at very long ranges. The manufacturing step is tightly controlled. Heat cycles, cooling rates, and grain structure are monitored because microscopic metal qualities affect wear and accuracy. Barrels often receive additional treatments: stress relief, cryogenic processing, or match-grade finishing, to normalize internal stresses and improve life and consistency. While steel is treated and finished, aerospace aluminum is machined on CNC centers into a single, solid chassis instead of two joined halves. That monolithic approach keeps the optical axis stable under brutal recoil. Magazines are stamped from stainless steel and sized for heavy magnum rounds like the .338 Lapua Magnum. Every finished part is checked to millimeter, often sub-millimeter, tolerances. Anything outside those limits is rejected and remade, because at long range, small errors become big misses. The delicate choreography of assembly. Assembly is mostly manual and demands steady hands and experience. Technicians use ultra-precise tools to join parts in a strict order. The barrel is mated and aligned to the chassis, so the bore and optical axis match perfectly. The bolt, which must contain the explosion and still not shift, is fitted to micron tolerances. Recoil absorbers and springs are installed to soak up forces that can be many times greater than on a standard rifle. The firing group, trigger, hammer, safeties, is finished to give a crisp, predictable break with no slack in the mechanism. That zero slop and reliable sear engagement are critical both for hitting the target and preventing accidental discharge. Before any live rounds are used, technicians run functional dry tests that simulate firing so only flawless assemblies move forward. In this work, a single small mistake can ruin accuracy or risk lives, so precision and inspection are constant. Technicians also perform fit and field checks on every rifle. They measure trigger pull weight, verify safety engagement points, and confirm that adjustable stocks and cheek pieces are set consistently. Jigs and optical alignment tools are used to confirm that rails, mounts, and bipod interfaces register to exact locations every time. Any removable accessory is test-mounted and reinstalled to ensure zero returns within tight margins. Documentation is updated at every step, creating a traceable build record that follows the rifle from bench to range. Surface treatments and the finishing touches. Sniper rifles get more than a coat of paint. They get a protective skin engineered to last. The primary finish is anodizing, an electrochemical process that grows a hard oxide layer on aluminum parts. That layer bonds to the metal, so it doesn't chip like paint, resists corrosion, and takes wear far better than ordinary coatings. The result is the flat, low-reflective surface you see on tactical rifles. It cuts glare, survives salt, mud, and sweat, and keeps moving parts sliding smoothly instead of seizing up. After finishing, the rifle is assembled outward from the perfectly tuned internals. Stocks and adjustable butt plates are fitted so the shooter can set length of pull, cheek height, and angle for a consistent eye-to-scope relationship during long waits. Handguards and front grips are attached to stabilize handling and provide mounting points for accessories. The upper rail, the spine for optics and add-ons, is installed and aligned to the same tight standard used inside the action. If the rail sits even slightly off, a scope won't track correctly at long range. Customization at this stage is mission-driven and extreme. Suppressors, where allowed, reduce sound and flash. Extended or match-grade barrels alter velocity and harmonics. Thermal and night scopes change engagement windows. And electronic aids, like digital wind compensation modules, can be fitted to assist under variable conditions. Each attachment is tested for repeatability. Removing and remounting a scope should return to the same zero within tiny margins. Some rifles are finished as limited runs, engraved, serialized, or camo-coated for desert, woodland, or urban use. But cosmetic choices never override ballistic function. Every trim, texture, and finish decision exists to protect zero, reduce signature, and ensure the rifle performs the same on the first shot and the 1,000th. Live fire testing. This is the rifle's moment of truth. After bench checks, each rifle is taken to a controlled range where technicians run a step sequence. First, they confirm basic function, ensuring that it feeds, fires, extracts, and ejects smoothly with several types of ammunition, because a jam at distance is a mission killer. Once mechanical reliability is proven, precision testing begins. The scope is dialed so that the point of aim matches the point of impact at set distances, commonly 100 meters, 500 meters, and 1,000 meters. And long-range models are pushed well beyond 2,000 meters to confirm that the entire system, including rifling, barrel behavior, and ammunition, works together. While shooters fire, high-speed sensors and chronographs record muzzle velocity, time of flight, and shot dispersion. Technicians compare those numbers to strict acceptance criteria. Even tiny deviations can send a rifle back for rework. Accuracy checks are immediately followed by abuse trials. Dust and mud, heavy rain, repeated full-power firing, deliberate drops, and rapid temperature swings. After each stress event, the rifle must still feed reliably and hold zero. Beyond pass-fail data, teams look for trends, a slowly widening group, a consistent shift at certain temperatures, because those patterns point to fixable issues like chamber sizing or barrel harmonics. Only units that meet both the surgical accuracy tests and the harsh durability trials earn the label field ready. Preparing the tool for the field, passing the range isn't the end, it's the handoff to the field. Every rifle is cleaned like a precision instrument. All powder residue, metal shavings, and fingerprints are removed, and a carefully measured film of lubricant is applied only where needed. Technicians log every serial number, calibration setting, and test result in the rifle's build file, so it's always accessible. Packing is designed to protect that work. Each rifle is placed in custom high-density foam inside a rugged, military-grade case with separate compartments for scopes, bipods, cleaning kits, and spare parts. Cases have airtight seals, reinforced hinges, and lock points. Tactical shipments add tamper-evident seals, shock-rated protection, and desiccants to control moisture. Every accessory is labeled and inventoried so units can be serviced quickly in the field. Finally, every rifle and its case are engraved and scanned into inventory systems, barcodes or RFID, to maintain chain of custody and support future maintenance. The goal is simple and strict. The rifle must arrive at its destination clean, zeroed, and ready to work the moment it's needed. Distribution and who gets these rifles. After packing, rifles move into logistics. Batches are palletized, labeled, and grouped by destination. Small shipments to authorized dealers might travel by insured courier, while military deliveries are created and often moved by air or sea in sealed containers. High-value or sensitive loads can travel under armed escort in armored trucks and are tracked continuously with GPS and manifest checks at every handoff. Export controls and approvals shape who can buy a sniper rifle. Governments, militaries, and certified security firms must provide end-user certificates and licenses before a shipment clears customs. Because of these rules and because each rifle costs upward of tens of thousands of dollars, ownership is tightly restricted. Manufacturers prioritize elite users, special operations forces, counter-sniper teams, embassy protective details, and other vetted units that require precision tools and after-sales support. Support doesn't stop after delivery. Authorized users receive documentation, spare parts kits, and often a warranty or service contract. Many manufacturers offer scheduled maintenance, barrel replacement programs, and training on proper mounting and zeroing. That lifecycle support is part of why procurement agencies buy from established makers. It keeps rifles accurate and mission-ready for years. So that's how a sniper rifle is made. A chain that starts with simulation, moves through fire and precision machining, passes human hands under microscopes, and finally proves itself with live fire and torture tests. It's engineering married to craft. Built so the first shot at the farthest range is also the last you'll ever need to take. Comment: have you ever seen one up close?